Hello students, welcome to this particular session, and in this particular session we are going to continue with numericals. Some very interesting numericals based on finding the average speed and average velocity in various cases, right? So let's start with a very interesting question. Suppose, let us assume a person starts from his home and reaches a market. He reaches a market which is at a distance of 2.5 kilometer from his home with a speed of say 5 kilometer per hour. So what I have considered is a person starts from his home and goes to a market which is at a distance of 2.5 kilometer from his home with a speed of 5 kilometer per hour. On finding the market closed, the person comes back to his home with a constant speed of say 7.5 kilometer per hour, right? So what my question is, you are supposed to find out the average speed and average velocity during the time interval t equals to 30 minutes. Second part is during the time interval t equals to 50 minutes. And third part is during the time interval t equals to 40 minutes. So these are the three parts of this particular question. Right? First and foremost, these are the 2 points A and B. Suppose the distance between A and B is 2.5 kilometer. So look, first and foremost, we'll find out the time taken by the person to reach from point A to point B. Right? So we'll try to find out TAB, time taken by the person to reach from point A to point B. Now in uniform motion, when the speed is constant, you are aware, time is given by distance over speed, isn't it? This is the formula. So in covering the distance from A to B, what is the distance covered? 2.5 kilometer. Right? And with what speed the person is covering this distance? 5 kilometer per hour. It is 5 kilometer per hour. So what you get is 1 by 2 hour, right? And in minutes, if you convert it, so it will be 60 by 2 minutes, and that is, it will be 30 minutes. Fine? This is the first part. So basically the person, while moving from his home to the market with a speed of 5 km per hour, takes 30 minutes to reach the market. So this is clear. Second step is to find out the time taken by the person to come back from the market to his home, right? So for that, let's find out TBA. Again, same formula, distance over speed. So while coming back, he is covering the same distance of 2.5 kilometer. And with what speed it is coming back? 7.5 kilometer per hour. So it is 1 by 3. 2.5 divided by 7.5 is 1 by 3, and the units will be in hour. Let's convert it in minutes, right? So it will be 1 by 3 into 60 minutes. So that will be 20 minutes. So obviously, while coming back, he rushes to his home. He travels with a greater speed. So it is but obvious it takes much lesser time in coming back to his home. So 30 minutes in going from home to market, and again from market to his home back, he is taking 20 minutes. So what is the total duration of his journey? 30 plus 20, that is 50 minutes, right? So you need to remember this fact. Now let's solve each and every question. Now solution. Let's consider on the first part. After a duration of 30 minutes, we are supposed to find out the average speed and the average velocity. So a person starts from here, t equals to 0. initially. So after 30 minutes he will be over here. After 30 minutes the person will be at point B. So during this 30 minutes he has travelled along a straight path in the same direction, right? So whenever a body moves along a straight path in the same direction, its average speed is equal to average velocity, right? So in this case, average speed would be equal to average velocity, which in turn would be equal to 5 km per hour. No need to solve it. It is already given the uniform speed. So this will be its average velocity, this will be its average speed. So whenever the speed is constant, then the instantaneous speed is equal to its average speed, which is what I have written over here. So after t equals to 30 minutes, what will be the average speed or average velocity? Both would be equal to 5 km per hour. So no need for any sort of calculation. Now second, after the duration of 50 minutes, t equals to 0, he will take 30 minutes and again further 20 minutes to come back over here. So 30 plus 20. So he will reach home after 50 minutes. Right? So after 50 minutes, what he does was, he moves from A to B and again he moves from B to A and comes back to point A. So total round trip is completed in 50 minutes. So students, look, during the entire interval of 50 minutes, the person's initial position is coinciding with his final position. So what is the displacement? It is 0. So therefore average velocity throughout the entire journey is also 0. So average velocity for a duration of 50 minutes would be 0, because during this 50 minutes the person is coming back to his home. So displacement is 0, therefore average velocity is 0. What about the average speed? Now let's make use of the formula directly, which we have derived in the earlier section. I have told you, whenever there is a case of a body covering equal displacements in unequal intervals of time, then the average speed is given by the harmonic mean of V1 and V2. So what is the formula? Twice V1 V2 divided by V1 plus V2, isn't it? So we can easily solve it. So let's substitute the value. Twice V1 is 5, V2 is 7.5, and this is 5 plus 7.5. So what you get is 10 into 7.5 divided by 12.5. This get cancelled. So 25, 375, 25, 5. So it is 6 km per hour. So what is the average speed for the time interval of 50 minutes? It is 6 km per hour. What is the average velocity during the time interval of 50 minutes? It is 0. Clear? So that's the second part, right? Now this is very, very interesting. This is very interesting. Let's consider the third part. For interval t equals to 40 minutes. Now look, students. In the first 30 minutes, he will reach from point A to point B. In the next 10 minutes, he is taking total of 20 minutes and coming back from B to A. So in 10 minutes, he will be exactly at midpoint. Midpoint means if this is 2.5 km, so this distance would be 1.25 km, half of 2.5. Half of 2.5 is 1.25, isn't it? So look, this is t equals to 0. At the start, the person starts moving towards market. He reaches market at t equals to 30 minutes. And he reaches point C after t equals to 40 minutes. Total time taken by the person to move from B to A is 20 minutes. So in 10 minutes, he will be exactly at the midpoint of his home and market. So after the duration of 40 minutes, he will be covering this distance. He will reach at point C. So after t equals to 40 minutes, A is initial point and C is final point. So let's calculate average velocity. You are aware, average velocity is displacement, net displacement divided by time taken, right? Displacement during this 40 minutes. This is the initial position, this is the final position. So what is the displacement, students? it is 1.25 kilometer, right? This is the initial point and this is the final point. Displacement is the shortest possible path between the initial and the final position given by a straight line, right? So this is the displacement, A to C, 1.25 kilometer. What is the time taken? 30 plus 10, that is total 40 minutes. You can convert this 40 minutes in hour, so it will be 40 by 60. Because we want to represent velocity or speed in terms of kilometer per hour. So what you get is 1.25 into 6 by 4, that is 1.25 into 3 by 2, which in turn will give us 3.75 divided by 2, which is 1.875 kilometer per hour. So this will be the average velocity of the person during the interval t equals to 40 minutes. Clear? Now the last part is left. During the interval t equals to 40 minutes, you are able to calculate the average velocity. So let's find out the average speed during this interval. Let's determine the average speed. Now average speed, we all are aware. Average speed is total length of the path, that is total path length divided by total time taken. Total time taken. So we are dealing with this case for a duration of 40 minutes. So what is the total path length covered by that person during 40 minutes? That is 2.5 kilometer plus 1.25 kilometer. 2.5 plus 1.25 kilometer. This is the total path length of the person after 40 minutes, right? Total time taken is 40 minutes. 40 minutes in hour will be 40 by 60 hour. So you can easily convert it, right? So it will be 3.75 divided by 2 by 3. So it will be in kilometer per hour. So we can easily solve it. Right? So it comes to be 5.625 kilometer per hour. So this is the average speed of the person. So student, this was a very, very important question. I think this numerical must clear your concepts related to speed and velocity. Related to speed and velocity. Right? So you need to consider, while talking about speed, we need to consider the actual path length. And while talking about velocity, we need to consider the displacement. Right? And when displacement is 0, average velocity is 0. Right? Let's consider a second numerical. A simple one, relatively a simple number. Okay, my question is, a person drives his scooter with a speed of say 40 kilometer per hour for first half an hour. Right? Again, I am repeating the question. A motorist or a person drives his scooter at a speed of 40 km per hour for the first half an hour. Right? And he drives with a speed of 60 km per hour for the second half hour. What will be his average speed and average velocity if the person is assumed to be moving along a straight path in the same direction? That is, consider the motion to be one-dimensional. Right? So students, think over it, which formula to be used? Look, here the duration is same. So we are supposed to consider the case where the body covers unequal distances or displacements in equal intervals of time. And students, we have already discussed the formula to be used in such a case, right? Whenever there's a case of a body covering unequal distances or displacements in equal intervals of time, then the average speed or average velocity is given by the arithmetic mean of V1 and V2. Arithmetic mean, right, which is sum of all the observations divided by total number of observations. So in this case, since the body is moving along the same straight path, so average speed would be equal to average velocity. It would be simply equal to V1 plus V2 by 2. This is the arithmetic mean. Again, I must remind you, if the body covers equal displacements in unequal intervals of time, then this formula is used. Twice V1 V2 divided by V1 plus V2. This formula is to be used when the body covers equal displacements in unequal intervals of time. But here, it is the case of equal intervals of time. So here we will make use of this formula, which is the arithmetic mean of V1 and V2. Right? So, let's solve it. Okay, it can be easily solved. It will be 40 plus 60 divided by 2. Obviously, it will be 50 km per hour. Simple. So students, all the numericals are simple. The only thing is the concept should be very, very clear. Right? You need to understand the formulae to be used appropriately. Read the question very, very carefully and then try to recall or recollect the appropriate formulae. Right? So this was another question related to average speed and average velocity. Let's discuss some graphical question. Right? So, let us consider position time graph to be given. Let us consider position time graph to be given like this. This is the third question we are attempting. This is it. Suppose this is time which is given to be in seconds. 1, 2, 3, 4, 5 and suppose 6, right? And this is suppose the position. This is suppose the position given. So let us consider to be 5, 10, 15, 20, right? And suppose it's given in meters. So we are talking about XT graph or position time graph. Suppose the graph is like this. Okay, this is the graph. This is suppose A, this is B, this is C, and this is D. Suppose this is the graph given, right? We are supposed to find out the average speed or average velocity. We are supposed to find out the average velocity when the body or between the time interval t equals to 0 to t equals to 2 seconds. Second is t equals to 2 to t equals to 4 seconds. And third is between the interval t equals to 4 to t equals to 6 seconds. These are the time intervals during which the velocity of the body is to be determined, right? So students, first and foremost, you need to write the coordinates. You need to write the coordinate and abscissa of each of these points. So what are the coordinates over here? It's 0, 10. What are the coordinates over here? It's 2, 10. What are the coordinates over here? It is 4 and 20. Over here, it is 6 and 0. So, first step is to write the coordinates, right? Second step is most important one. We are aware the slope of position time graph, gives the velocity, this is a crucial and important point. In the previous session, we have discussed it. The slope of the position time graph will give the velocity, right? That should be our approach. In order to find out the slope, we need to find out the coordinates first. The slope will give us the velocity, right? And slope is y2 minus y1 divided by x2 minus x1. That's the formula for the slope, right? What is the slope in case of AB? Let's consider first part. That is from time interval 0 to 2. 0 second to 2 second. Okay, that is from A to B. What is the slope from A to B? There is no slope. The line is flat. It is parallel to the horizontal axis. The slope is 0. So the speed must also be 0. The velocity of the body must be 0 over here. Because slope is 0. You can verify this fact. The velocity of the body from A to B, that is from t equals to 0 to t equals to 2 seconds, right? It can be considered to be x1 y1, it can be considered to be x2 y2. Consider it to be x1 y1, consider it to be x2 y2. What's the formula for this slope? y2 minus y1. Look, y2 minus y1, 10 minus 10 divided by x2 minus x1, that is 2 minus 0. So if numerator is 0, it will become 0, right? So also make use of your common sense. With the passage of time, the position of the body remains fixed. It means that the body must be at rest. The body is not moving at all. So if the body is not moving, so its average speed or velocity would be 0. So from A to B, that is during the time interval t equals 0 to t equals 2 seconds, the slope is 0, which is what we have proved. Therefore, velocity is 0. Right? Let's consider the second case. We need to find out the velocity of the body during the time interval 2 to 4 seconds. 2 to 4 seconds. This is 2, this is 4. That is from B to C. Okay. Now consider B to C. B is the initial, C is the final point. Consider this to be x1, y1, this to be x2, y2. And the formula for the slope is, as I have told you, it is y2 minus y1 divided by x2 minus x1, right? And slope of position time graph, xt graph, will give us velocity of the body. So let's proceed. y2 minus y1. This is y2, this is y1. 20 minus 10, right? Divided by x2 minus x1, 4 minus 2. So that will give us 10 by 2, that is 5 meter per second. It's in meter, it's in second. So this velocity of the body during the interval t equals to 2 to t equals to 4 seconds, that is from B to C, is 5 meter per second. Let's consider the third part. We are supposed to find out the velocity during the interval from 4 to 6 seconds. 4 to 6 seconds. This one, 4 to 6 seconds. So what do we do? It is from C to B. Again, y2 minus y1. Now consider this to be x1 y1 and the final point to be x2 y2. So what's the formula? y2 minus y1 divided by x2 minus x1. y2 minus y1, that is 0 minus 20 divided by this minus this, x2 minus x1, 6 minus 4, that is minus 20 by 2, that is minus 10 meter per second. The velocity of a body can be negative. It represents the direction, basically, the negative sign. So the velocity of the body during the interval t equals to 4 to t equals 6 seconds, that is from C to D, is minus 10 meter per second. So students, I must again tell you the significance of the position time graph. The slope, mark my words, please mark my words, the slope of the position time graph will give the velocity of the body under consideration. Right? That is what we have done out over here.